Aircraft that flies from Alpha to Bravo, maximum permissible takeoff mass 82,000 pound, maximum mass without fuel and traffic load 50,000 pound. That means dry operating mass. Landing mass 69,000 pound, fuel trip fuel 16,000, reserve fuel 3,000. What is the maximum traffic load that can be carried? So to find that out, let's make two columns, one for takeoff mass, another for landing mass. Okay. Now in the takeoff mass column, you are going to write the maximum structural takeoff mass value, 82,000 pounds. In the landing mass column, you are going to write the maximum landing mass value, which is 69,000 pounds. And to that, you are going to add trip fuel, which is 16,000 pounds. Make sure all the units are same. Okay. So 69,000 16,000 is 85,000. So your regulated takeoff mass will be a lower value. So in this case, 82,000 is the lower one. So that becomes your regulated takeoff mass. Step 2. Payload will be equal to regulated takeoff mass minus DOM plus fuel on board. So 82,000 minus DOM 50,000 pound, fuel on board. It is trip fuel plus reserve fuel. So 16,000 plus 3,000 is 19,000. 82,000 minus 50 plus 19, 69. So 69,000 minus 82 is 13,000 pound. Okay. So we have option Bravo and Charlie 13,000, 13,000. Second part of the question, is it possible to carry additional reserve fuel without affecting the traffic load? Right. So your takeoff mass is 82,000. Your landing mass is 85,000. Okay. So there are two possible takeoff mass values, 82,000 and 85,000. So that means, let's say the difference between them is 3,000, right? The difference between them is 3,000, correct? So let's say you take off with 85,000 pounds. Okay, will that be allowable or acceptable, permissible? No, because at the place of departure, your takeoff airport is limited up to 82,000 pounds of value. If you take off with 85,000, that will be exceeding the 82,000. Okay, so that means you cannot carry this additional 3,000 pounds. Okay, if you want to carry additional 3,000 pounds, your takeoff mass value should be more than landing mass value. Only then you can carry it. Okay, so that's why. So the correct answer will be no. You cannot carry additional reserve fuel or additional anything because of the takeoff mass limitation. So option Bravo is the right option. 67. A flight is to be made from Mike to November and return flight to Mike carrying maximum traffic load in each direction. Fuel is not available at November. So fuel is not available at your destination aerodrome. That means at the place of departure itself, you will have to carry two types of fuel. The fuel required for one-way distance and the fuel required for return flight. Okay. So distance between them is 80 miles. Ground speed M to N 70 knots. Ground speed N to M 110 knots. Fuel consumption 410 kg per hour. Takeoff mass at Mike 6,180. Landing mass at November 5,740. Takeoff mass at November 5,800. Landing mass at Mike 5,460. Zero fuel mass is given. Aircraft mass less fuel and traffic load DOM is given. Reserve fuel is given. What is the traffic load each way? Step 1. You are going from Mike to November. Okay, so going from Mike to November. So let's say this is your Mike, this is your November. The total distance between them is 80 nautical miles. And ground speed from Mike to November is 70 knots. So flight time will be distance divided by speed, 80 divided by 70. So 80 divided by 70 is 1 hour 8 minutes. Flight fuel will be flight time into fuel consumption. So 0108 consumption 410 kilogram per hour. That is 468.57. Let's say it's 469 kilogram of fuel. That is fifth fuel. That is flight fuel. Next, fuel on board is flight fuel plus reserve fuel plus return journey flight fuel. Okay, because there is no fuel supply at your destination. So at the point of departure itself, you will have to carry the flight fuel required to come back from November to Mike. So you will require return journey flight fuel as well. So flight fuel from Mike to November is 469. Reserve fuel which is going to remain unused 250. Plus the fuel required for return journey. Now how to calculate that? For return journey, return journey flight fuel equals to flight time return journey multiplied by fuel consumption. Now how much time you will require to come back from November to Mike? So the distance remains the same, 80 nautical miles. Now ground speed on return flight is equal to 110 knots. Fuel consumption rate is 410. T into 410 divided by 110, 298. So you require 298 kilograms of thrift fuel for your return journey. So I'm going to add 298 here. So total fuel on board at the time of departure is 469, 250, 298, 1070. Now next step, takeoff mass column, landing mass column, zero fuel mass column. In the takeoff mass column you write the takeoff mass limitation. So maximum takeoff mass at departure is 6180. Landing mass column, maximum landing mass at destination 5740 plus trip fuel. What is the trip fuel from Mike to November? It is equal to 469. 6209. Zero fuel mass 5180 plus fuel on board. Right? So what is the fuel on board at the time of departure? 1017. 6197. Your regulated takeoff mass will be the lowest value. So here the lowest value is 6180. 6180. Okay. Next step, payload equals to payload on the first leg of your flight, regulated takeoff mass minus DOM plus fuel on board. So 6180 minus fuel on board 1017. Dry operating mass is 4400. 4400 plus 1017. 5417. So that is 763. So that, so on your first leg, on the first leg of your journey, you can only carry 763 kg of payload. Very less, very little. So either option alpha or bravo. Now let's calculate traffic load on the return flight. Now on the return flight, takeoff mass column again, landing mass, zero fuel mass. Okay. So takeoff mass limitation, maximum takeoff mass at November. Now we are coming back from November to Mike. So pay attention. Maximum takeoff mass at November is 5800. Maximum landing mass at destination. Now our M or Mike is your destination. So it's 5460 plus trip fuel. Trip fuel required for return flight is 298. Zero fuel mass 5180 plus fuel on board. Now on a return flight journey, fuel on board will be flight fuel plus the reserve fuel. That's it. So 298 because it's a return flight. So all the fuel that will be available in the fuel tanks will be the flight fuel required and the reserve fuel unused 250. Correct? So 298 plus 250, 548. 5728. 5758. So select the lowest value. So here the lowest value is 5728. Right? So that becomes your regulated takeoff mass. Payload on this return flight will be regulated takeoff mass minus dry operating mass plus fuel on board. So 5728 minus dry operating mass of 4400 plus fuel on board 548. That is equal to 780. So 780 is option alpha. So option alpha is the right answer. Next. 68. Maximum takeoff mass, regulated takeoff mass, maximum landing mass, regulated landing mass, and maximum zero fuel mass given. DOM is given, aircraft approved for service. Trip fuel, reserve fuel. What is the traffic load? Okay, so again, takeoff mass column, the landing mass column, the zero fuel mass column. In the takeoff mass column, you are going to write the structural takeoff mass value given to you and the regulator takeoff mass value given to you. So the lesser one. So write 50,000, 50. In the landing mass column, you are going to write the maximum structural landing mass value or the performance limiting landing mass value, the lower value. So structural is 44.3, 44.2. Regulated landing mass is 43.2. So write that 43.2 plus trip fuel. Trip fuel is 4.2. In the zero fuel mass column, you write the zero fuel mass 45.1 plus fuel on board. Okay. So fuel on board is trip fuel plus reserve fuel. So 4.2 plus 1, that is 5.2. Okay. So this we are doing, we have made these three columns in order to find out a final takeoff mass value. Okay. So first takeoff mass value, direct value given. You can find out takeoff mass value using landing mass. Landing mass plus trip fuel is takeoff mass. Another way to find out takeoff mass is zero fuel mass plus fuel on board. That is the third way to find out takeoff mass. Now 43.2 plus 4.2 is 47.4. 45.1 plus 5.2 is 50.3. Now select the lowest value. The lowest value here is 47.4. So that becomes a regulated takeoff mass. Load will be equal to regulated takeoff mass minus DOM plus fuel on board. 47.4 minus 5.2, DOM is 27.5. 2.7. That is 14.7 ton or 14,700. So option Charlie. Next. Maximum takeoff mass, landing mass, DOM, TAS, track, wind component, distance, fuel consumption, reserve fuel given. What is traffic load? So write down takeoff mass column, landing mass column. In the takeoff mass column, write the takeoff mass limitation 80,000 pound. In the landing mass column, write landing mass limitation which is 60,000 plus trip fuel. Now how to find out trip fuel? Trip fuel equals to time, your flight time multiplied by fuel consumption rate. Okay. Now how to find out time or flight time? It's flight distance divided by ground speed into fuel consumption. What is flight distance? 1350 divided by ground speed. Now we will use CH3 to find out ground speed. Fuel consumption is 2500. Okay, CH3. So wind correction, TAS. TAS is 200 knots. Course 50. Ground speed is 180. 1350 divided by 180 into 2500 is 18750. So that is the trip fuel required. So add this 78,750. Now regulated takeoff mass will be the lower value. So this becomes a regulated takeoff mass. Load will be regulated takeoff mass minus dry operating mass plus fuel on board. So dry operating mass is 48,000. Fuel on board is nothing but trip fuel plus reserve fuel. So 3,500 plus 18,750. 32,250. 70,000. So 8,500. ठीक है 8,500 pounds option bravo. 70. Maximum structural takeoff mass, landing mass, zero fuel mass given, DOM given, fuel consumption rate, distance, reserve fuel, task is given. Winds, a headwind of 20 knots halfway, thereby changes to 60 knots tailwind. Find maximum traffic load in still air. Find maximum traffic load with winds. Now see, maximum traffic load in still air 9,000, 9,000, 9,000, right? So we need not find the answer to option or question number 1. It will be a waste of time. Let's find out maximum traffic load with winds. Okay. So now total distance is 1,500. A to B 1,500 is 20 knots of headwind halfway distance. What is half of 1,500? It is 750, correct? So that means for the first 750 and the next 750. So first 750 we have a headwind of 20 knots. So that is your headwind. And for the next 750 we have a 60 knot tailwind. We have a 60 knot tailwind. So focus on this first part of the journey. Distance is given, task is 260. So task 260, headwind component 20, ground speed 240. So time of flight time will be distance 750 divided by ground speed 240, 3 hours 7 minutes. Now here task is going to remain same 260, tailwind 60, ground speed 320. So flight time on this part of the journey, the second part, the next half of the journey, distance divided by ground speed 320, 2 hours 20. So total flight time 3 hours 7 minutes plus 2 hour 20 minutes. So it is 5 hours 27 minutes. So flight time 5 hours 27 minutes. Flight fuel is flight time multiplied by fuel consumption. 0527, fuel consumption 1600 kilogram per hour. 8720. So 8720 is the flight fuel. Fuel on board will be flight fuel plus reserve fuel. So 8720 plus 2750. 11470. ठीक है. Takeoff mass column the landing mass column, the zero fuel mass column. In the takeoff mass column, you write the takeoff mass limitation 55,000. Landing mass column, the landing mass limitation 52,000. Strip fuel. What is strip fuel? 8720. Light fuel is your trip fuel. Zero fuel mass column, zero fuel mass limitation 38. Fuel on board, which is 11470. 52,000, 8720. 49,470. Now the lowest of these is 49,470. So this becomes your regulated takeoff mass. 49,470. Payload is your regulated takeoff mass minus DOM plus fuel on board. So 49470 minus 11470. What is your DOM? 29,000. 11,470 plus 29,000. 40,070. So that is 9,000. Correct answer is 9,000. So option alpha. Okay. So this concludes the lecture. I hope you have understood all the 5 questions I have answered in this video lecture. If you have any questions or feedback, let me know in the comment box. In my next video lecture, I will do the next remaining questions. I request you all to subscribe to this channel, share this video with your friends, and hit the like button if you have liked this video lecture. See you.